already know the derivative of sine and cosine. Well, now it's time to learn the derivative of our four other trig functions. To determine the derivative of tangent, I'm first going to rewrite tangent as sine of x over cosine of x. And I can get the derivative of sine of x over cosine of x using the quotient rule. I'll multiply the bottom times the derivative of the top, and then minus the top times the derivative of the bottom. And I'll put that all over the bottom squared. Notice in the top, I have cosine of x times cosine of x. That's cosine squared x. And then I'm subtracting sine of x times negative sine of x. Well, that's like adding sine squared of x. I know cosine squared of x plus sine squared of x equals 1. I get a result of 1 over cosine squared of x, which I know is secant squared of x. So the derivative of tangent x is secant squared x. This would be a great time to pause the video and see if you could use a similar method on your own to derive the derivative of cotangent of x, secant of x, or cosecant of x. Did you have any luck? Well, either way, we're not going to use this process every time we need to get the derivative of a trig function. These are 6 derivatives that a calculus student needs to have memorized. Hopefully by the end of the lesson, or at least by the end of your assignment, you'll have these 6 trig derivatives memorized. Let's take a look at example number 1, where I'm asked to find the derivative of y equals x minus tangent x. This should be pretty simple because it's broken up into 2 pieces with a subtraction symbol. So the derivative of x, of course, is 1, and then I'll just subtract the derivative of tangent, and the derivative of tangent is secant squared x. My derivative is 1 minus secant squared x. Number 2 will be a bit more difficult because I'm asked to get the derivative of x times secant of x. I'm going to need to use the product rule. X is my first piece, and secant of x is my second piece. Of course, when we use the product rule, we're going to put the first piece times the derivative of the second piece. And the derivative of secant x is secant x tangent x. Then plus the second piece, which is secant x, times the derivative of the first piece, and the derivative of x is 1. And of course, secant x times 1 is just secant x. There's not much more I can do here, but I do suppose this first piece has a secant of x in it, and the second piece has a secant of x in it, so I could factor out the secant of x. But just because I factored it out, that doesn't mean I can throw it away like it doesn't matter. Here's one way to express f prime of x, and here's another way to express it. Here I want to get the derivative of f of x, which is expressed as a fraction, so I suppose I could use the quotient rule. So my derivative will be the bottom times the derivative of the top, and the derivative of the top is 0 minus negative sine x, or in other words, positive sine x. Then minus the top, and the top is a binomial, so I better put that in parentheses. Times the derivative of the bottom, and the derivative of the bottom is cosine x. And that's all over the bottom squared. Let's see if we can neaten this up a bit. I know sine of x times sine of x is sine squared of x. And then I'm going to subtract what I get when I distribute that cosine of x, so I better put this in parentheses. Of course, cosine of x times 1 is cosine of x. And then minus cosine of x times cosine of x is cosine squared of x. I think I'll distribute my negative. And I may not have any like terms in the numerator, but I do have a positive sine squared x and a positive cosine squared x. And I know sine squared of x plus cosine squared of x equals 1. I'm going to say my derivative is 1 minus cosine of x over sine squared of x. Now, it might be fun to go back and tackle this one in a different way. Let's rewrite this. 1 minus cosine x divided by sine of x can be rewritten. You see, 1 divided by sine of x is cosecant of x. And of course, cosine of x divided by sine of x is cotangent of x. So let me now get the derivative of cosecant x minus cotangent x. And the derivative of cosecant x is negative cosecant x cotangent x. And then I'll subtract the derivative of cotangent of x, and the derivative of cotangent of x is negative cosecant squared of x. Of course, this subtraction of a negative is a positive. Now, we should be getting the same answer as we got before, so let's see if these are equivalent. Let me rewrite this. I'm going to rewrite everything in terms of sine and cosine. But negative cosecant of x is negative 1 over sine of x. And then times cotangent of x, which is cosine of x over sine of x. And then plus cosecant squared of x, which is 1 over sine squared x. When I multiply these two fractions, I get negative cosine of x over sine squared of x. And I then need to add my 1 over sine squared of x. And how convenient is this? We already have a common denominator of sine squared of x, so the numerator would just be negative cosine of x plus 1, just like we got before. In number 4, I'm being asked to evaluate the derivative of f of x at the point pi over 3, 3/2. And this just means I'm being asked to find the slope of f of x at the point pi over 3, 3/2. So of course, we're going to need to get the derivative of f of x, and we're going to use the product rule because f of x is sine x times tangent x. So my derivative should be the first times the derivative of the second. So the first times the derivative of the second, and the derivative of tangent x is secant squared x. Plus the second, so plus tangent x, times the derivative of the first, and the derivative of sine is cosine. Now, perhaps f prime of x could be simplified, but that's not really important. We're being asked to evaluate f prime of pi over 3. I don't really see a point in trying to simplify it. I think I'll just plug in pi over 3 the way it is. So let's first think about what sine of pi over 3 is. Here's pi over 3. Sine is how high it is. It's radical 3 over 2. Before we think about what secant of pi over 3 is, we need to consider what cosine of pi over 3 is. And cosine of pi over 3 is 1/2. If cosine of pi over 3 is 1 over 2, then secant of pi over 3 is 2. And of course we need to square that. 2 squared is 4. Then we're going to add tangent of pi over 3. And of course tangent of pi over 3 is the slope of this steep line. Tangent of pi over 3 is radical 3. And finally, cosine of pi over 3, we already said cosine of pi over 3 is 1/2. So over here, I have 4 root 3 over 2, plus, and over here, I have 1 root 3 over 2. And 4 root 3 over 2 plus 1 root 3 over 2 is 5 root 3 over 2. Apparently, the slope of f of x at the point pi over 3, 3/2 is 5 root 3 over 2. Let's take a look at one last example where we're going to perform the classic task in calculus. Determine the equation of the line tangent to the function at the point 2, 4. When we're asked to write the equation of a line, we need a point and a slope. We already have a point. We just need the slope of this function at the point 2, 4, so we of course need the derivative of this function. My function is expressed as a fraction, so I'll of course use the quotient rule. I'll put the bottom times the derivative of the top, and then minus the top times the derivative of the bottom, which is 2x. And I'll put that all over the bottom squared. Let's neaten this up a bit. I'll distribute the 16. 16 times x squared is 16x squared, and 16 times 4 is 64. And then minus 16x times 2x is 32x squared. I see I have some like terms I can combine in the numerator. This positive 16x squared and negative 32x squared combine to make negative 16x squared. Now I can use my derivative to determine the slope of this function at the point 2, 4. I just need to evaluate f prime of 2. When I plug in 2, 2 squared is 4, and negative 16 times 4 is negative 64. Negative 64 plus 64 is 0. And when I plug 2 in the denominator, 2 squared is 4, 4 plus 4 is 8, and 8 squared is 64, but 0 divided by 64 equals 0. I know my slope is 0, and now I can write the equation of the line. Y minus my y value of 4 equals 0 times x minus my x value of 2, but of course 0 times anything is 0, so y minus 4 equals 0, or we could say y equals 4.
Let's take a look at this one on our graphing calculator. Let's graph 16x divided by x squared plus 4. And I'll draw the line tangent at the point 2, 4, or where x equals 2. We get y equals 2.5 times 10 to the negative 7, which is essentially 0. We get 0x plus 3.9999999. We get 0x plus 4, or y equals 4. Okay, time to go get those try these done.